All right. It looks like we're right on time. And we've got a couple attendees in the list. So if you guys are ready, let's go ahead and get started.
Awesome.
All right. So I want to thank everybody for coming. This webinar is on choosing the best PC and graphics for SOLIDWORKS. The presenters here, I'm Steve Darcey from GoEngineer, applications engineer. So I'm pretty much a nerd. And we got Matthew Allard on. Good.
Yep, and I'm pretty much a nerd too, Steve. So you got good company here. I manage alliances, our strategic alliances here at Dell for our Precision Workstation group.
All right, and then we got Melissa Farrow.
Hi, everybody. My name is Melissa Farrow. I work for Dell Financial Services, and I work with end users to offer a payment solution that fits their business needs.
All right, thanks, guys. So first, I'm going to go through really quickly what's new at GoEngineer. Of course, we've expanded our territory. Our corporate office is in Salt Lake City, Utah, and I'm actually out of the Austin, Texas office here. Expanded territory, what does that mean for you guys that are using SOLIDWORKS? It means that we have longer tech support hours. So if you're Central Time, it's really good for you guys because we got 7 a.m. to 7 p.m. We do mentoring sessions. If you are with SOLIDWORKS and you're on the support, the subscription, then you get one of these, or we can do an entire group throughout the year. We can customize it to your needs. And pretty much what we're doing is just a little 1 to 2 hour session to where we can, you guys can pick any topic and we'll customize it for whatever your needs are. So try and use those mentoring sessions. They're free to you. We do have 3D printing. We do FDM, resin-based. We now have powder-based fusion, and we also have metal printers. So if you want more information on that, contact us on those. And of course, our training, we've kind of upped the ante on that. We are now, COVID's starting to die down a little bit. We are starting to do in-house classroom training for public training, but we also do online, self-paced, and custom training. All right, and just released on the 16th of November was the customer portal. So if you guys have accounts with GoEngineer, you can actually log into your own account. You can look up serial numbers. If you're the admin for the account, you can actually add users and delete users and kind of do a little bit of clean up on your own company. You can also look up tech support cases, and you can also log tech support cases on there. So you can also do some reporting in there to find out, how much tech support do you guys actually use throughout the year. So pretty cool little thing. All right, so turn it over to Matt real quick, and he can tell us a little bit about what's new with Dell. You're muted still, Matt. Sorry.
I did it, didn't I? Classic mistake. Hey, so just as a reminder, we at Dell, we're continuing to kind of move our precision portfolio forward. And for folks that may not have parsed it before, it's pretty simple. Essentially, it breaks down into 3 series, 3000, 5000, and 7000 series. And we have mobiles, towers, and rack workstations, each one of those. The way to think about it is like the 3000 series are kind of our entry level. It doesn't mean low performance, just means it's our kind of, less expandable. They tend to be on the lower end of the high performance of precision workstations. As you move up the series to 5000 and 7000, they become, in the tower, certainly they become larger. You can actually expand them greatly with more storage and multiple GPUs and way more memory and that sort of stuff. The only wrinkle here in this is the 5000 series mobiles also happen to be our thin and light machines, and we'll show you a little bit more about those shortly. But we've been coming off a very, very busy summer and into a busy fall. We shipped all new mobiles this summer, and so we'll show you some of those shortly here, and a couple of new towers, which I'll show you one of those at least. So lots going on. I also just point out we have some rack units. So for people that like to keep their compute in a data center kind of environment, those are really ideally built for that.
Great. All right. Thanks, Matt. I'm going to go right on into, we're going to be tight on time, so we're going to rush right through these. So I want to start talking about SOLIDWORKS Core, large assemblies, parts, and drawings, and kind of what we need for CPU, RAM, motherboard, fast SSD drives, graphics, and then what the solution in either the desktop and the laptops are. We're starting to get companies that really have some very, very large assemblies. You can kind of see I've got some pictures of some huge ones, up into 30 and 60,000 parts. So just to kind of put it in perspective, the average car has 30,000 components in it, 30,000 pieces that you have to build to put it together. Okay, we do have some customers, I thought I had a different slide, that have very, very large ones. Now, when you look at these, you kind of say, well, what are the system requirements for SOLIDWORKS? What do I need? As you always have kind of a minimum and then a medium and then the high end. And people always ask me, what kind of computer should I buy? And I always ask them, I put it back on them and say, what's your budget? Because if you have a big budget, then totally, I'll tell you exactly what you need to buy is this $14,000 computer. But depending on what your budget is, you just got to kind of have to fit for what you want. If you go to SOLIDWORKS website, then they're going to say, oh, all you need is Windows on there. If it can run Windows, it can run SOLIDWORKS, right? Then you go to the hardware side, and the hardware side actually lists Quadros, NVIDIA Quadros. And so then you're starting to get into more of a upper end workstation or laptop when you start talking about specific graphics cards that fit in specific computers. So then the real question is kind of this, is if you buy a Lamborghini, should you run the Lamborghini on gravel or should you run it out there on a racetrack? So you buy SOLIDWORKS, SOLIDWORKS is your Lamborghini, and it makes no sense to be driving that thing in gravel. You're not going to get a very good feel of what the product can do or how fast it can actually perform. So, with Dell, with the right types of motherboards, processors, graphics cards, you're going to be able to just, fly. You need to take that thing to the limit. All right, moving on. So here's an assembly. It's got 175,000 components in it. And you can kind of start to max out what a computer can do on these things when you're doing an open and a save. And I'll talk about this a little bit more in depth in just a bit. But when you open an assembly like this, it has to run through a set of procedures every time. So you're stuck with how fast can the hardware run it. And so on an assembly like this, you will look at, sometimes 45 minutes to an hour just on an open time. And so, how do you get rid of that waste is by buying faster hardware. All right, so a little bit about large assemblies. Again, I'm not going to go step by step through here, but for the most part, it is single cord. We do have to kind of go in and open up a part, update the part, once the features are up to date, solve for that at the part level, then solve for it at the assembly level where parts are actually going together against other parts. And then once those are all done, then we can display them graphically where they're at, and then update the painted display and then kind of go from there. Drawings is pretty much the same thing. In the background, we got to open up the parts, then we got to open up the assemblies, and then we've got to do the hidden line generation for the drawing views. So, drawings actually take a little bit more longer just because we have to load up the parts and the assemblies in the background. So mostly single cord. You do need fast hard drives, just depending on what the size of assembly that you're opening. And once the file's open, your NVIDIA Quadro will make it to where you're actually going to like the experience or you're going to hate the experience. And when you start getting into where the file starts to drop frames, kind of what I call it, then it's time to upgrade and get a better graphics card. All right, so what is the part? If you ask people what it is, oh, it's this stuff in the feature tree. It's an extrude and a revolve and a sketch and a feature and all that stuff. But it's not only just that. Once the individual part gets open, it's also the graphics on the part. So, here's a very simple block. We have to actually tessellate it into triangles so we can render it on the screen. Typical bolt has about 500 triangles. If you actually did a revolved thread, now we're looking at 5,500 triangles that the graphics card has to keep up with just for a single bolt. If you actually did this as a helix and a cut, now you're looking at 23,500 triangles for a single bolt. So if you think about how many bolts might be in your assembly, you could actually render it as 500 triangles versus 23,000 triangles. So you got to really kind of take a look at what graphics card you need and how much it can actually handle. All right, so for SOLIDWORKS Core, there is support for multi-core. So when you open an assembly, we can actually open up multiple sub-assemblies and parts at the same time. And then once those sub-assemblies are up to date, then we just got to solve the mates at the top level assembly. So on open and save, we can have some support for multi-core, multiple CPUs. Whenever we're importing or exporting to a different file format, a lot of times, you know, faces in different locations can be exported and imported. Whenever we're calculating the drawing views on a drawing, that's multi-core. We already have the assembly up in memory, and we already know what the top view and the side view and the right side and the isometric, so we can actually start rendering those through the multiple cores. And then when you get to rendering threads, surfaces, and curves, like the loft command and the sweep command, you know, going up to the point of the loft command is single chord, but once you hit the OK button, because we're doing sections on lofts and sweeps, then we can actually do that with the multi-threaded CPUs. But for the most part, it's a single chord. We need some kind of NVIDIA graphics, memory, you know, it's going to depend on the assembly size. Of course, fast SSD drives. And let's talk about what do you got for us, Matt, on laptop and desktop configurations?
Okay, cool. Let's see. This is great. I love how you kind of break this down because you make it into kind of real world what your customers are doing with SolidWorks. And so we picked a couple of our 3000 series to start for SolidWorks Core because it's good entry level machines. So the 3561, this is a really nice machine. It does support you know, a quad core processor, so it has some multi-core functionality in it. It has a 4 GB NVIDIA graphics card in it, so you know, decent size memory in the graphics card. One of the things that's really important about this series is we've moved them to what's known as PCIe Generation 4, Gen 4. You see there flagged. Gen 4 is actually a faster communication means to and from the storage where your models and your projects are kept and into memory and into the GPU. And so the fact that we do Gen 4 storage, that M.2 SSD is a very fast interface to the storage itself. You can put up to 64 gigabytes of memory, so plenty of memory for what you're doing, and it's fast memory to boot. And we've done some things to make sure that when you're exchanging data between CPU and GPU, you actually get better performance. So all this stuff really lends itself well to this kind of basic view that Steve's described, where mostly single core, a little bit of multi-core, fast drive, fast memory, and really the whole communication between the central processor and the GPU working together. We've done some other nice things, making a better keyboard, larger touchpad, and it's a pretty nice screen. It's bright at 400 nits, and it covers a pretty wide color space as well. And one of the things I'll point out, you know, I know most of you who run SolidWorks probably are looking at it all day long. I know even I don't do that, but I'm on my computer all day long. Low blue light, that's what that LBL is. We call it Comfort View Plus. Reduces the blue light emissions from your screen. It's just something that's been shown to be fatiguing for your eyes, not good for your eye health. So nice feature in the mobile here. So a really pretty capable mobile, not too heavy at 4 pounds. You know, we wouldn't consider this our thin and light, but it's still no slouch from that standpoint. Why don't you go to the next slide? We'll show you a desktop now. So this desktop is really actually a screamer. It's an amazing desktop at, you know, kind of the top of our entry-level 3000 series. So the 3650, this can go up to 8 core. I'm sorry, that's a typo in there. It's not 10, but 8 core. So you can have 8 core processors. This can support a very beefy graphics card all the way up to the latest NVIDIA Ampere generation of cards. Those were just announced this summer, all the way up to RTX A5000, which is an incredibly high-performing card. That sits on that PCIe Gen 4 architecture, so it has very fast communication to the storage, which is also Gen 4. It can be. And then very fast RAM all the way up to 128 gigabytes. So you may not need that, but the beauty of this system is that you can expand down the road. If you want to start with 32, you can get to 64, you can get to 128 on this particular machine. You have some nice options in this one, including Wi-Fi support is optional with Wi-Fi 6, so you have latest Wi-Fi, and you can get 2.5 gigabit Ethernet if you want a slightly faster Ethernet as well. So really an amazing machine. It's one of the smaller machines we make, but it really is a very, very fast performer because of the things I've mentioned. So this machine will make SOLIDWORKS Core screen for sure.
Nice. All right. Thanks, Matt.
Yeah.
So next we're going to go with SOLIDWORKS Visualize. So talk a little bit about some of the graphics settings and some of the rendering. So give me a second. Let me pull up. So I've got Visualize on here. And this looks like it's a photo, but in reality, this is actually a live 3D model of this car. And that's what Visualize is. If you're on subscription and you're in SOLIDWORKS Professional or Premium, you automatically get this. It's included with your software. So we can do some kind of fun stuff if we come in here and get maybe some metallic paint. And I want to see what it looks like blue. And just drag and drop. And this uses a lot of everything. So if I go to my options here, there we go. And go to my 3D viewpoint. You can see that it actually uses NVIDIA and it can also use the CPU. So it's going to try and peg those things out as much as possible in Visualize. So it's some pretty amazing stuff. And that's not even the rendered, but you can kind of see we get some real good reflection control on that, some ray tracing. I mean, it just looks really amazing. All right, so with that, give me a second. Start the so pretty much what I need on this machine is high-end GPU, of course NVIDIA, and then CPUs multi-threaded, and you may want to talk a little bit about the right display on this one because you can kind of see on the slide when you render these things, they look good. So kind of to get that excellent detail to where people don't know that it's fake. I mean, that's kind of what we're going for here. So let's see what you got for us on this one. Let me switch slides. All right, there you go.
Cool. All right. So what I decided to show is something from what we would call the middle of our lineup, our 5000 series. And this is our thin and light in the mobile. So this is actually a 17-inch thin and light. I used a predecessor to this that has the same chassis, and it feels more like a 15-inch. The screen's literally a 17-inch screen, but there's almost no bezels on it, as you can see on this picture on the right. So it's all screen. I put it into a 15-inch bag. I don't need a special bag for it, but I get all the real estate. So here on this mobile, you'll see we go up to 8 cores on this machine. And these can be very fast cores for those sort of more single-threaded, single-core operations. What makes this really great for Visualize is you start to come up in the NVIDIA product line. And particularly with this, you get up to an NVIDIA RTX A3000. Now, again, the A stands for that Ampere generation of graphics, the latest generation that they've produced. And RTX is where you get accelerated ray tracing. And the latest versions of Visualize do leverage that hardware, leverage that GPU hardware that's specifically built for ray tracing to accelerate that photorealistic performance in your viewer. So it's really powerful and a big 6 gigabytes of graphics memory as well. For the system, it also supports Gen 4 storage. So again, loads and saves, you're going to be working through a very fast storage and a very fast interface to that storage. Up to 64 gigabytes of memory, and you basically add these in pairs. There's a slot, 2 slots. To Steve's point about displays, so we have a really great option for display on this this model where you can get a UHD or 4K display. It's actually a little bit bigger than 4K, why we call it UHD plus. It's 500 nits of brightness, so it's quite bright. It's actually rated for high dynamic range imaging, something you guys may not do as much. But what's really important is that 100% Adobe RGB. That describes the color gamut that you cover when you're looking at the screen, how many colors it can reproduce. That's significantly more than the 100% sRGB on the last mobile I showed. And it's much more like what you'd see in a photograph. So when you're rendering, it's nice to have wider coverage, like 100% Adobe RGB. So if you're doing, you're doing work for Coca-Cola, you would be certain that the Coke is, their logo is the right red and things are going to look the right way. The other number there, this 99% P3, this is actually a video color space. So if you're generating videos, again, if you want that accurate, what you see is what you get environment, you want to make sure you have, full ability to see on screen what you're going to deliver ultimately to your customer or client. Higher speed Wi-Fi on this machine with the Wi-Fi 6. So it's really an amazing machine in terms of overall performance, especially because of the GPU capability. I don't want to understate that, especially for Visualize.
All right.
Let's take a look at a desktop. So our mid-range desktop, this thing is kind of crazy as a mid-range because it really shows you how we differentiate between what we would call 3,000, a starting place, to a mid-range. In the mid-range, now you start talking about a lot of cores. And so in Visualize, if you're leveraging both CPU and GPU, you can get up to 18 core processors in this machine, which is pretty amazing. And you'll notice that there are CPU options that give you turbo speed up to 4.5 gigahertz. So this is an important consideration. The gigahertz is the speed. So you got the number of cores and you got the speed. If you're doing a single core operation, the faster it is, the better. And what turbo does is during certain functions which are single threaded, it'll actually boost the speed up for that short duration. So it's nice to have those little bumps when you're working. This can be upgraded to up to 512 gigabytes of RAM. So for really your largest projects, your largest designs, and you can put up to 2 RTX 8000s or the RTX A6000, one of those right now. So it's an amazing machine in terms of expandability for additional graphics. And this is what we talk about when we talk about, the product line with precision scales. As you go up, there's actually more power, more physical space, more for drives, for storage, for bigger GPUs, and for GPUs. And lots of flexibility in terms of configuring additional storage around it. But this is a very flexible machine. It's super popular because it's very quiet, but really gives top-end power in this form factor. Again, great for SOLIDWORKS Visualize.
All right, thanks, Matt.
Yeah.
So next I'm going to jump into simulation. So we're kind of getting into the part where we're leaving the slow, small stuff and we're going into the heavy hitter kind of thing. So a lot of people ask how many CPUs, how many cores, the faster the GPU, does it make a difference? And how much memory and hard drive space do I actually need to run some of these things? So I've actually got, let me go in the show real quick. And we'll pull up SOLIDWORKS. All right, and I'm going to start with something fairly simple. I got a quick little bracket. And a lot of times when we run something in simulation, we actually just do half of it. And while I run this, I'm going to squish this over. Whoop. A little bit. So we can actually see what my computer's doing. And this is a tool I use all the time. It's just Task Manager. Go into the CPUs. In the CPUs, Windows defaults to do this overall utilization. I like to see all the cores out there so I can see, and this is a Dell laptop, so this is not a desktop. I have been running some simulations lately, so it is actually, it gets some heat on it. But I'll kind of explain a little bit more about that. You can see the memory, the SSD drive is just sitting there doing nothing, and that's the three things that you really want to start looking at. When you start looking at memory, you know what processes are actually taking up the memory. You know, go to the process, sort by memory, and sort by CPU, see who's eating up all the memory there and the CPU. And take a look, you know, when you open up a large assembly, if you have 32 gigs of RAM like I do, and I open this assembly and I'm up to 28 gigs of RAM, well, guess what? I don't need more memory. It's 28 gigs of RAM. That's what it is. You know, unless I open up more of an assembly, it's not going to go over that. So it's still going to be as fast whether I have 28 gigs or whether I have 32 gigs versus 64. You know, it really only gets slow when you get to that 32 gig or about a gigabyte underneath whatever that top limit is that you have. So, you know, this is about a 3-year-old laptop, but it runs pretty good. So let's run some simulation real quick. I have just a little standard. Cut this thing, so I added simulation. I've got a load on it. The back of this is being stuck, so it's bonded to something, or those elements can't move. And let's run it. Now the crazy thing is, this pretty much in the old days used to take about a minute. And you'll see it already meshed it. Now it's running the study, so it's processing it. And now you can kind of see that there's what it is. We've got the stress on there. And if you look at my CPU, it started going up a little bit, but it didn't do much at all. You know, it's not really hammering that thing too much. In fact, just doing some of the graphics right here is actually kind of keeping it at a steady state there. All right, so then we can get a little bit crazier. I'm going to do an H-adaptive study, which means it's going to run a mesh, run a study, run a mesh, run a study. Whenever the higher stress plots are, it's going to mesh it again in those areas a little bit more dense. So this is my first pass it's running. So you can see the mesh elements are a little bit large. Then it's running it again. It's going to tighten it up. So in some of these little areas down in here, you can kind of see that it's starting to tighten the mesh up, make those elements smaller and smaller. And that gives me a little bit better a more precise amount on there. All right, looks like I think I got one more. So running 5 loops on that. And you can see that, you know, I am using all processors on that thing. I've got 12 processors on there, and it's going to town. So, and this is just pure simulation. You can see what that looks like. It's pretty good. All right, let's move on to something a little bit crazier. So that's just a single part. When you start getting into an assembly, now we have to mesh multiple parts. And we may want to put multiple loads on here and run these. I'm going to rerun the results for this. Now my mesh element size is a little bit more coarse. It's not actually tightening like it did on the last one. And you can see I'm not letting off of my CPU. It's just hanging out there. Now my memory really hasn't changed too much. You know, once the files are loaded in RAM, when you run a simulation, it will actually kind of go up a little bit as it solves a part of the simulation and then writes to memory, and then up a little bit and up a little bit. And then once it actually solves it, you'll actually see memory drop down a little bit, but it's not, you know, not a whole lot. Now, when we get to flow and we get to plastics, those are totally different. Those we'll talk about. They get quite large quite fast. So when we're just running static FEA analysis, you know, not too crazy on this side. Maybe I want to interrogate this design a little bit. Let's turn off our all right. And we can do a little animation on this one as well. So as I wasn't really doing too much, the CPU started to drop a little bit. But now we're starting to render some of this stuff. And I have to, that's the thing you got to think about is I have to calculate it first. Once I calculate it, then I can send my pretty colors, I'll just call them that, send that to the graphics card, and then we can display them on the screen. So yeah, a lot of times you'll see, oh, well, my CPU is way up here and my, my GPU is not hardly doing anything. Well, we got to wait till that's done before we can hand that stuff off. All right, so that's looking pretty good. So that's a regular simulation. Now we'll go into
Steve, I'm going to just make, if you don't mind me making one point.
Yeah.
For folks that may not know, I'll make this one comment. In Steve's task manager, you see those 12 unique processes, and in fact, his machine is 6 cores. So the way Intel works is they generally have a number of cores, and those break into 2 logical processors per. So I've been talking about 8 and 10 core machines. You can then double the number of logical processors. So just want to be clear what you're seeing there and how that relates to what I'm showing as well. Thanks, Steve.
That's the hyper-threading.
Yep, exactly.
And that's kind of, I think, the difference. If you buy a low-end machine and it only has an i5 or an i3, you're not going to get the hyper-threading on that. You won't get that separated core. So it's on the i7s, the i9s, and then the Xeons. Do they have hyper-threading on those too?
Oh, you bet. Yep.
Okay, perfect. All right, so now we'll go into the hard hitting. This is a simulation for flow analysis. And again, it's all kind of set up. I've got air coming in. Let's go ahead and remesh it as well. Hot air coming in, and then the air has to kind of go out through the different little nozzles. And so we're going to see how this pans out. This does, this is actually a small analysis. When you start getting into an assembly where you have a whole bunch of parts, this can really start to take some pain on your computer. That's I've actually blown up. I forgot to, every once in a while I spray out my it's got little fans in the laptop, so I got to put the air on it, and you got to clear all that stuff out. If it gets too dusty in there, you can burn up the CPUs on there. And so a long time ago, probably 6 years ago, I burned up the CPU just because I didn't. When the guy opened it up, he was like, "Man, you got dust all in that thing." So keeping that stuff cool, that's something you really have to pay attention to. All right, so the way that flow analysis works, it works off of iterations. So it can break this thing up as many times as you want. So the more CPUs you got, the merrier. And I will tell you, that's kind of the issue that I'm having right now on my CPU, is that once my CPU gets up to a certain temperature, Dell will actually start making this thing not go as fast. So notice my speed up here. Usually when I do turbo mode, it can get up to like 3.5 gigahertz. But now that all my processors are just like cranking, it has to slow that thing down a little bit just to make sure that it doesn't die on me. So we'll finish.
Exactly. This is a great point, because we're managing the heat dissipation. When you're doing something that exercises all those processors, it heats up, and we'll try to vent as much of that heat as possible. If we can't, we drop the performance down so you don't have a failure like you described. That's really the intent. Again, it goes to keep your machines clean. keep those vents free, because we're doing everything we can to get air to the system to keep it cool.
Yeah, and I had one of the thin. I do a lot of travel, so I have the thin, small laptop. So it's a little harder on the heat dissipation on that one.
Yep.
That's some of the other AEs I go and I'll race them. We'll open up the same file and they have the little thicker, and I make fun of them. Oh, look how thick and big and heavy that thing is. But when we hit the run button, I'm not going to say they double the amount or half the amount of time that it takes to solve one of these, but it's pretty close in there. They can do them a lot quicker.
Oh yeah. I'll illustrate that when we show the machines next. But you'll see an equivalent. Yeah.
All right. So it solved everything. You can kind of see the CPU kind of drop down a little bit. Here's some of my little flow lines. We can do a little animation on those. So we can see where the actual air is going. And you know, the thing you want to do on something like this is you want to engineer it to where you have the same flow rate as you do in the first one versus the last one. And so you really need to kind of play with the geometry and make sure that, you know, the tool is actually doing what it should, and I don't have, you know, air in one that's like 10 times higher or, you know, velocity or pressure than the other ones. You want to try and make sure that they're all equal. And that's what makes a good design. The better the design, the more money hopefully your company will make. All right, so that's good enough cool stuff with that. Let's go ahead and switch back to the PowerPoint. So one thing I didn't show is plastics. And plastics, I will tell you, it is it uses just as much power as flow analysis, because it is a crazy thing. So here we go. What do I need? I need a fast CPU. I'm sorry, this was for a simulation, but all multi-core. The faster, the more, the merrier. High-end NVIDIA graphics, and max out the amount of memory for flow and plastics. So let's see what you got for us on those.
Yeah, so this kind of makes the point is, you know, when I showed that last mobile, the thin and light 5760, you know, we've done a ton to actually do a special thermal solution in that. That's, you know, specifically engineered for that model to move as much heat out as possible. But your statement's right on, Stephen, which is, if you have more space in the machine, which this 7760 is our 17-inch really highest performing machine, what you'll see is, you know, the number of cores is not bigger than the last machine at 8 cores, but we can give plenty of power, and we have plenty of power to store for the GPU, the graphics as well. So where that 5760 could go to an A3000, this can go all the way up to an A5000. And I'll just say, not all A5000s are created equal. It depends on how much power you give them, how much electrical wattage you give them. And in the 7760, because of the physical space and our ability to cool it, we can get up to 115 watts to that A5000, which is amazing. So this makes it a very high performing machine because of that space. Now, because of the space, we also have more expandability. We can actually put up to 4 M2 SSDs in this machine, which, if you were having problems with your disk performance because your models were so big, or you were trying to write so fast, your saves were slow, you can actually RAID those disks together. So, you know, by RAIDing them together, you can get higher performance than just using one drive alone. So there's some nice things in this machine in terms of configuration options. Higher speed memory with this, including a super speed memory option at 3466 megahertz. So that's pretty amazing. And again, really nice screen option here. The 4K screen supports the 500 nits brightness at that 100% Adobe RGB and 100% P3 coverage on a HD monitor. So really, really nice system overall. The one thing I'll point out about this system that is unique than any of the others, in the 7000 series, we do support 5G radios as an option, which means if you're in an area where there's an active 5G rollout, you could get high performance mobile networking, which is pretty cool. So I think, you know, that opens up an opportunity for some interesting workflows in the field. So that's the 7760, our most powerful. And again, you know, it kind of goes to that story that Steve was teasing out, which is, if you want to, you know, keeping things cool is really critical to keeping the power up. And this is a machine that's really built for that. All right, go ahead. So we're back at the 5820 tower, because again, this gives you that flexibility. With 18 cores and hyperthreading, you get 36 logical processors out of this machine. So again, a ton of processors, a whole lot of high-speed memory, your choice of very capable graphics, including multiple graphics cards options. and huge expandability for storage and other stuff. And you'll notice we noted the advanced thermals. I think this is exactly it. These are all engineered for their thermals to make sure that we're venting out the heat when the system's under load and being used aggressively, like in simulation. I like that Stephen was showing the task manager because it really illustrates how the machine is used during these kinds of workflows. And there's a piece of software that's available on all Precisions called the Dell Optimizer for Precision. And it leverages that information and how you use your machine to tune the machine for what you do every single day. So if you're doing something that, you're doing a lot of simulation regularly on the machine that uses the CPU a whole lot, we can tune the machine using an artificial intelligence approach to deliver better performance when you're doing that simulation. And it's something we learn over time, as I said, with an AI approach, and it can deliver 5-10% performance gains as it learns how you work and the kinds of operations that you do and how it leverages the machine. So it's a bit of intelligence. It's not just about the spec of the machine. It's about how we tune the machine for performance, whether that's our engineering around thermals or the actual software engineering we do through this Dell Optimizer software. So
nice. All right.
So cool. I think we covered a bunch of ground here. I wanted to give Melissa a minute to talk a little bit about Dell Financial Services and ways you can acquire these machines that may work even better for your business. So Melissa, I'd like to hand the floor to you if you would like.
Sure, thank you, Matt. So we can go on and jump into it. Next slide. Oops, sorry, my screen froze. Okay, there it is. It popped up. Sorry about that. So in today's business IT world, right, businesses face challenges. In addition to digital transformation, they include like CapEx budget constraints, worries about over provisioning, managing unpredictable growth, getting the most out of useful life of technology. And if you want to jump to the next slide, we do have payment.
Yeah, we have a poll. Do we need the poll right now, or when do the polls go?
It's on a later slide.
Okay. All right. Thanks.
Yep. So our payment solutions are designed for predictability, flexibility, and choice. Go back so that I can read my notes, make sure I don't skip over anything. Our organizations are continually to be asked to do more with less. So being able to spread technology costs over a time in a foreseeable way, even when workloads are variable, can be a valuable strategy to maximize cash flow for businesses. DFS solutions allow for simplified, predictable budgeting, billing, technology lifecycle management from desktop to a data center. You can go to the next slide. Okay, so with our Dell Business Credit account, it is only offered for purchases directly from Dell. Dell Business Credit is a revolving line of credit that allows your business to preserve cash flow with no money down, low monthly payments. Dell Business Credit can help to build your business credit profile to give you a dedicated technology line of credit. There are no annual fees. There's no prepayment penalties. You can pay your bill online, by phone, or by mail, and you can also set up automatic payments. And then we can hop to the next slide. So we also offer a pay-as-you-go program with technology rotation and ownership solutions. Jump over to the technology rotation slide. So this is pretty broad. There are several scenarios where it makes sense to use technology rotation strategies, such as like deploying lifecycle asset management. It's a way of acquiring IT hardware while only paying for the use of the equipment, not its ownership. So at the end of technology rotation, you have the options to refresh your equipment, purchase new. You can extend the term for up to an additional 18 months, or you can purchase the equipment for the fair market value at the end of the term. And then we'll jump over to the technology ownership slide. And our technology ownership program, it's pretty simple. At the end of this option, you would just own the equipment. So we offer simple finance structures that make it easy to budget, plan for your ownership costs. It removes the burden of expensive upfront costs for IT acquisition, preserves cash for other investments, and it offers a complete solution for affordable technology. And we'll hop over to our operational expense. So with our OpEx versus CapEx, this is where the poll question comes into play. Is that already typed up? There we go. So if you guys want to answer the question, does your business utilize operating expense or capital expense when it comes to technology purchases? Give a couple minutes to answer the poll. You want to go back to the slide, I'll continue talking about the OpEx, CapEx. So operational expense versus capital expense, you want to look at the benefits of financing and payment solutions that are directed more towards your business to enable the infrastructure, accelerate your ROI, increase operational efficiency, and simplify your budgeting and payment solutions. So you can spread your IT costs over several cycles, retain cash for investing more into your business. And then we'll hop over to the next slide for the pay-as-you-go promotions that we have going on currently. So these are our promotional rates that we have going on right now. The technology rotation is a negative 7%, which means you'll save roughly 10 to 11% over the original purchase price. The rotation option, again, allows you to send your equipment back at the end of the term, extend the term to up to an additional 18 months, or purchase the equipment for what is considered fair market value at that time. And then the technology ownership program is 3.99% for 36 or 48 months. And again, at the end of this structure, you would just own the equipment. And then we also offer different options where you can do 90 days of a payment deferral, or we do have promotions going on throughout the year where we can do 6-month payment deferral as well. And then if you go to the next slide, this is kind of what it looks like, or the process that it looks like to finance with Dell. So you would contact your Dell sales rep, discuss your hardware needs. They will then provide a quote, software quote, hardware quote if needed, and we will combine all those to provide a single monthly payment estimate, and then we send over to you to review. You'll look at the agreement, everything looks good, you'll ask questions. If all is well, we'll put the order into production, and after the order ships out, you will receive your first statement. And then off to the next slide. And so what we want to do is make it easy for our customers, work with Dell and GoEngineer to provide a single monthly payment so that you guys can purchase the equipment that you need at an affordable price and great rates. So if you have any questions, I've got a contact listed here, Alicia_bowling@dell.com, to get started today.
So they can actually finance SolidWorks as well as the hardware with this solution.
Correct, yes. We can bundle it all into one monthly payment, so they're not having separate bills come in for different projects or solutions that they have purchased.
Nice. All right. Well, with that, if you guys want to get started, you can go to dell.com/GoEngineer. That's going to be the website that will allow you to kind of look at the hardware. With GoEngineer, we kind of have taken kind of a small, a medium, and a large. And so you can go into each one of those and start configuring, as you see fit. But with that, I want to thank you guys for all coming. We are going to do a question and answer, but thanks for attending the webinar. All right, so let's go ahead and do a question and answer. We do have some Q&A stuff come in. One is the picture of the gravel that just came off the internet. It took a while to find a Lamborghini with stuck in gravel. I always used to just say that to people, why buy a Lamborghini and run it on gravel? But to see an actual picture, that was pretty cool. And then we got another question. The company already uses a Dell in-house, and they don't do a lot of rendering and stuff, but they do need faster clock speed. Does Dell do overclocking? So Matt, we'll turn that over to you.
Yeah, not in precision world. We try to shy away from that because these are sort of tightly engineered to be predictable and run very well at high performance speeds. And I know we do this in the gaming side, but we are a bit more conservative in the way we engineer and design precision. So it's not allowed on the precision side of the business.
Okay. All right, we've got another one. SOLIDWORKS 2022. Right now, it's still in a pre-release state. It's set to come out on November 23rd. If you watch this later, it may already be out. And it will not be compatible with Windows 11 right now. Okay, so let me kind of refer to what compatible means. Will it run? Yes, it will run on it. Will SOLIDWORKS support it? Probably not until Service Pack 1. So we'll just have to wait and see when they actually post it on the website as to whether or not, more than likely, it's going to be a yes is going to be the answer. We do have some of the AEs have already installed Windows 11 and are running the pre-release, so it does work and function on it. But it's just the thing of, yeah, we are supported and it's on the website finally.
Yeah, and when you get there with SolidWorks on Windows 11, all the machines I showed you today support Windows 11 already. In fact, we have the option of shipping them with Windows 11 today. So I wouldn't advise that until you guys get that fully certified. But of course, just want to let you know that we're ready for it when it comes.
So when you order it, you actually tell them whether you want Windows 10 or Windows 11?
The customer gets to pick that. Yep.
Okay. Perfect.
Yeah, we just made that transition very, very recently in the last couple months anyway. So.
All right. Awesome. All right, looks like that's it with our questions. I'll wait about, we got another one popping in, hold on. Got to scroll down. So a lot of people using SketchUp. So SketchUp is Google SketchUp.
Yep.
It does 2 dimensions and 3 dimensions. So, is a rendering software as well. Right now, I guess they're using Xeon V2 3 gigahertz chips. So, if you look at, and there's kind of a difference. When you look at the laptops, you'll see that the CPU gigahertz is way smaller than it is on the desktop side. And yep. I'm guessing that has more to do with the heat dissipation or longer battery life, that kind of thing you have to take into consideration for that.
Those are all the considerations for sure. But yep, we have people that use SketchUp on the machines all the time, so it's certainly possible. Yep.
And for the most part, most 3D software packages are using OpenGL. And, the NVIDIA Quadro series is going to render that stuff like slicing bread. Just
yep.
Pops right through it. All right, so I guess the question he says is rendering, it takes a lot of hours on the current chip. And good. If you
Yeah,
want.
I think it's going to depend on how they're rendering, right? So and what you've got set up for rendering. As you saw Stephen show in Visualize, it has the ability to do high quality rendering, leveraging the GPU, specifically rendering RTX. I don't know SketchUp well enough to know whether they've got an RTX render option as part of their render setup. But if they do, that would be a great thing to have if you've got an RTX card. If it's all being CPU rendered, then you know the old rule applies. It's as many cores as possible is what's going to make that go faster. So this used to be a very easy answer. When you rendered, just pay attention to cores. Now the answer is a little more subtle. It depends on how you're set up in your renderer, whether you've got the GPU renderer enabled and turned on, and particularly with RTX, there's nice acceleration there for ray traced output. So that's the digging I would do in SketchUp, just to understand what their renderer is doing. You can pop open the task manager, as Stephen showed. If you do a render and all those cores you've got in that machine are pegged way at the top, you know you're CPU bound.
And I guess one of the questions is going to be, is it going to be faster in SOLIDWORKS Visualize versus Google SketchUp? I don't know Google SketchUp enough. So the best way to do it is just to benchmark it. Send us a file, let us render it, let us do a demo for you and see what it looks like. Yep. And that's the thing, I won't know until I actually import it and try it.
Yeah, and all software vendors work a little bit differently in terms of how they optimize rendering and what code they throw at it. And obviously with the Visualize stuff, they're going to leverage whatever hardware is there. If you've got an RTX there, they're going to use it as long as you throw those flags in your setup. So I think, it may not be any faster on that machine, or it might be depending on how the software's been optimized.
Yep. That's a great question. Gets into some good conversations for sure.
And it's CPU for sure is what this person's saying. So thanks, Rasan, for confirming that. So yeah, if you see that, again, you can really learn a lot by paying attention to your task manager if you're seeing slowdowns. Watch your memory, watch your CPU, watch your GPU. That's gonna help guide you to a newer machine. And I'll just again remind you, older generation machine, if you've got older Xeon V2 setup that's dated, every generation of Xeon improves performance 10 to 20%. And so we're currently on 11th generation processors. Those are, again, another 10, 20% better than the last processor. So if you're a few years back, you could easily be, 40 or 50% or more faster simply looking at the CPU.
Yeah, I've got an old Microsoft Surface 3, and it'll run SolidWorks, but it's slow. Like driving in gravel for sure. So it's way better, when I'm working on the Dell laptop for sure, in workstation grade components. All right, one of the questions, what about using Vault to bring in assemblies? They load locally. That is correct. We have GoEngineer's done a couple YouTube videos on best practices with SolidWorks. And so that's, this we wanted to kind of handle what can we do on the hardware side? There are some tools on the software side as well in SolidWorks to make sure that you are working the fast and quickest that you can. One of them is locally. Anytime I don't have to copy something over the network onto the local machine, because if you think about this, I've got a server out here and it's got a shared drive on it. Then I've got my laptop. The files actually have to come through the network. And once they come through the network, they got to actually funnel through the CPU and then get put into memory where they're supposed to. So that has to happen. If I've got a 30,000 piece assembly, that has to happen. And then once it's in memory, now I'm constantly working off of memory. There's no real connection to it. So I'm just as fast as my hardware is. But then once I have to hit the save button, guess what? All those files go all the way back across that network and have to go to that more than likely a spinning drive on the server. And that's a lot of time going back and forth. So with PDM, SOLIDWORKS PDM or Vault, what happens is all the files reside on the local client machine. And when the file starts to open up, a small little XML file goes to the server and says, hey, do I have all the latest releases of this assembly on my local machine? And so the server will already know. It'll say, oh yeah, you do, or it'll say, nope, you've got 2 files. So then 2 files get copied to your local machine. They are on a hard drive space on that local machine. So then, once it sends back and says, yeah, you got all the files, it opens up locally. So then you're just as fast as your client machine is. And then of course you got, a 10,000 part assembly, you change, 10, 12 parts, and then you save them locally, but it's not until you check the files in. When you check the files in, it only copies those 10 files over to the server side, checks those in, you get a new version in the Vault. So definitely working with PDM is going to speed up your open, your save times, and your stability for the most part. Because if you have some kind of network cut in between you and the server while it's open, there is a possibility that it can cause, an issue with saving back to that directory. Let's read some of these other ones, see if that helps out. Yeah. Yeah, and we're not really going to talk anything about networks. Everybody has their own networks internally. Whether you're using an older 100 megabit per second or 1 gigabit per second, or now they're getting up to 10 gigabit per second. So the network speeds are getting, much, much faster internally, as well as getting out to the internet as well. So yeah, I'll take your name, and we'll as long as you got your email address in there, we'll send some instructional videos for that. That's not a problem.
Awesome.
Yeah, fiber is extremely fast. That's the way to go for sure. I'm on one of the houses at the end of the cul-de-sac that they don't have fiber here yet. We got really high speed internet. It's up, 800 gigabit or something like that, but it's not at one. Or I'm sorry, 800 megabit per second. I'm not at a gigabit yet. Matt, what do you have there? Do you have gigabit? Do you have fiber going in?
Not in my house. No, it's no option for that. And I have to apologize. I have to jump to my next meeting. I know we're at time here, and I've got someone waiting on the next call, Stephen. So I
Okay.
apologize for having to exit, but I thought really great session, and appreciate the opportunity to speak.
Yeah, thanks, Matt. And that's looks like we're good on questions. So I'm going to go ahead and close up the meeting. Hope you guys enjoyed it.